Let's begin section 2 by defining a linear equation. You can see why it's called linear, because when we graph it, the graph is going to be a line. Root word. So here you go. A linear equation is any equation that can be written as. That doesn't mean it has to be written this way, it just means it can be written this way. Something times x plus something times y is equal to something. Any equation that could be written like that, if you graph it, it's going to be a line. Here's what I want you to notice. The x is being raised to the first power. The y is being raised to the first power. So therefore, many times you'll hear a linear equation defined as a first degree equation. And if you had my intermediate algebra class, we spent a lot of time talking about that. So when the x and y are raised to the first power, you've got a linear equation, and your graph is going to be a line. Now, do you notice that while ago, we went back to 7th grade, to Mr. Gibson's class, and we graphed x plus y equals 3 with a t-table? Notice that if your a was 1 and your b was 1, you've got ax plus by equals c here, and our graph ended up being a line, didn't it? Okay, so that's consistent with what we're saying here with our definition. Now, we're going to graph lines two different ways. Today, we're going to graph lines one way. Later in the chapter, we'll do it a different way as well. So today, we're going to graph lines by using the intercepts. Part B of our notes. Using intercepts to graph lines. My question is posed to Taylor and Michaela, and I pause for a moment before I ask it. Okay. Here's my question. How many points on a line do you have to have before you know what the line looks like? Well, you gave me two different answers, Michaela. You said 2 or 3. So what do you think? 2 or 3?
Let's go with 2.
Okay, let's see if you're right. If these were 2 points on a line, class, would you know what the line looked like? You would, wouldn't you? Michaela, you should have more confidence because you are exactly right. The answer was 2. 2 points determine a line. If you got any 2 points on a line, then you know what the line looks like. Now, the 2 points we're going to look for are these 2 points. Where the graph crosses the x-axis, referred to as the x-intercept, and where the graph crosses the y-axis, referred to as the y-intercept. So as long as I know those 2 points, I got 2 points on the line, then I can graph the line. So the question becomes, how do I find those 2 points? How do I find, let's consider the x-intercept first. How do I find the x-intercept? So Dustin and Amy, I want to talk to you guys now for a minute. I'm going to put a bunch of points up here on my graph. And what I'm looking for you to tell me is what you think these points would be. For example, you might estimate this point to be at negative 3, 0. 3 to the right, 3 to the left, and 0 up and down. So Dustin and Amy, what would you estimate that point to be?
3, 0.
Okay, what about this one?
Positive.
Okay, how about this one out here?
0.
It's interesting that on all of your guesses, your y-coordinate was always 0, wasn't it? Wouldn't that be true of any point on the x-axis? No matter what point you pick on the x-axis, the y-coordinate is going to be 0. So, to find the x-intercept, we're going to use that exact notion. To find the x-intercept, what we'll do is we'll put 0 in for y and solve. Because the x-intercept is going to happen when the y-coordinate is 0. Otherwise, it wouldn't be on the x-intercept. Now, Linnea and Shamari, what do you think I'm going to write then for how to find the y-intercept?
Put 0 in for x and solve.
Good. That's exactly right. Bless you, by the way. Put 0 in for x and solve. Why? Because no matter what point you have on the y-axis, the x-coordinate is going to be 0. So to find the x-intercept, we'll put 0 in for y. To find the y-intercept, we'll put 0 in for x. Okay, let's use those notions to do this first problem. So example 1 in your text. Somebody shoot me a page number on that. I'm not for sure what page it is.
372.
372, thank you. Says, find the x-intercept, y-intercept in graph 4x minus y is equal to negative 3. Let's find the x-intercept. Now, some people call this the cover-up method. Have you ever heard it called that? The cover-up method. Here's why it's called that. To find the x-intercept, I put 0 in for y. If I put 0 in for y, I would have 4x minus 0 equal to negative 3, which gives me 4x equal to negative 3, which I could have just got by covering up this y right here, right? So to find the x-intercept, cover up the y. 4x equal to negative 3, divide both sides by 4, and x equals negative 3/4. Now, if you want to get real technical about it, that's a point in the xy plane, so it has both an x and a y coordinate. So technically, the x-intercept is the point negative 3/4, comma 0. If you give me x equal negative 3/4, I'll live with that. Okay, so for the y-intercept, what are we going to do? We're going to put 0 in for x. When I put 0 in for x, that's equivalent to covering up the 4x. And I'll have negative y equal to negative 3. which would give me y equal to 3. If you give me that, I'll live with it. Technically, however, that's the point 0 for x, 3 for y. Well, we got 2 points on the graph. Now we can sketch the graph. So, here we go. Negative 3/4 on the x-axis would be 3/4 of the way to negative 1. So it's going to be like right in there. Zero, 3 will be 0 left and right and 3 up. Boom, shakalaka. There's 2 points on the graph. Here's the graph. Don't forget what we said earlier. What does that graph represent? It represents all the x and y coordinates that make the original statement hold true. A graph is a set of solutions. Dustin and Amy, are we making any sense here?
Yeah.
Okay. Well, if you're going to talk about lines and you're going to talk about slope, aren't you? You know what algebra mothers always say to their algebra teenagers right about the time they get their driver's license. They always say, I better not ever catch you smoking that slope. It's bad stuff. Don't be smoking slope, class. Don't be smoking slope. Come on, that one's kind of, I mean, that kind of tickles your bone a little bit. See, hey, I think that Malia might kind of like that joke a little bit. don't be smoking slope. That's good. I'm pretty proud of myself. Okay, well, what the world is slope? How many of you have ever done any roofing in your life? Tore off a roof and put a new one on? I mean, it's a lot of fun. It's just great fun. You get to get up on the roof when it's about 90 up there. It's got that black paper on it, so it's nice and hot. And you get to scrape all the old shingles off first and get all these blisters on your hands. Then you get to go down to the ground and pick them all up and throw them on the trailer. Don't leave a nail, because if Mr. Whatever runs over with his lawnmower, then he yells at you because you get a flat tire. And then you get to carry all the new shingles up there. Oh, wait a minute, you got to put new black paper on first. And then you carry all the shingles up there. They only weigh about 80 pounds a bundle, and you carry them up the ladder and throw them down and go get another one. It's just a great time. Well, anyway, when you're talking about roofs, if you talk to a carpenter or a roofer, they talk about pitch of a roof many times. A lot of houses that were built like in the 70s and the 80s, they had either a 412 pitch or a 512 pitch. For example, my house was built, the house we live in was built in the 70s, and it looks similar to what I'm getting ready to draw here. So what's a 412 pitch? It means if you take a point on the roof to get to another point on the roof, you're going to rise 4 as you run 12. So rise 4. 1, 2, 3, 4, run 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 412 pitch would be about that steep right there. So a 512 pitch means you would rise 5 as you run 12. So it'd be about this steep right here. So 512 is a little steeper than a 412. Okay? Now that idea of comparing the rise to the run, that's the same idea as slope. Same exact idea. The only difference is slope can be negative. Pitch they never refer to as negative. So let's think about that now. Let's put ourselves in the XY plane. Let's say this point is x1, y1. And this point up here is x2, y2. And let's talk about the line that runs between those. So, the slope of that line will equal the rise between those points over the run between those points. Wouldn't the rise be this distance right here? That distance. So here's either the third or the fourth time I've asked this question today. So let's see who's going to get it. Let's put Donna and Karina in the pressure seat here. How would I find this vertical distance right here? Donna says y2 minus y1, and she's exactly right. To get a vertical distance, you subtract the y's. Wouldn't this distance right here give me the run? And to get that distance, I would subtract the x's. That's x2 minus x1. So now if I put the rise over the run, I'm going to have y2 minus y1 over x2 minus x1. We'll shut the door there. It's going crazy out in the hallway here at Shawnee College. Everybody having a good time? Good to see. Thank you, Ms. Donna. So, many times in algebra, for some reason, we refer to the slope with the lowercase m. So there you go. There's the formula that you've seen time and time again for slope. Y2 minus y1 over x2 minus x1. It's rise over run. So sometimes students will switch those. They'll put the x's on top and the y's on the bottom, and maybe they forget which goes which. Look, it's rise over run, and rise rhymes with the y's. Rise and y's go together. So the y's go on top, and the x's go on the bottom. Okay, let's take a look at example 3, which asks us to find the slope of the line that goes through the points 2, -1 and -5, 3. So how are we going to find the slope? We're going to apply the slope formula that we just talked about. y2 minus y1 over x2 minus x1. Let's go back to Dustin and Amy for a moment. Here's another question I've asked multiple times today. Does it matter which point is x1, y1 and which one is x2, y2?
No.
You don't think it does? Okay. Which one do you want to be x1, y1 then, Dustin?
First one, 2 and negative.
All right, let's make that x1, y1, and let's make this x2, y2. Then as we plug in, y2 minus y1 will be 3 minus -1 over x2 minus x1 will be -5 minus 2. Three minus -1, same thing as 3 plus +1, so that's 4 over -7 or negative 4/7 for the slope. Now, let's say Dustin would have switched those. Let's say he would have made this one x2, y2, and that one x1, y1. Then what would it have looked like? y2 minus y1 would be negative 1 minus 3. x2 minus x1 would be 2 minus negative 5. A lot of people, when they get a negative on the second one, they forget the double negative. They just put one of the negatives. But do you see it's 2 minus negative 5 here? To be negative 4/7, or still negative 4/7. So he's right. It doesn't matter which way we label them. I get negative 4/7 either way. But I want to remind you of something that you probably already know. We're claiming that 4 over negative 7 and negative 4/7 are the same thing. Well, how is that true from a slope perspective? Let's take 4 over negative 7 first. So if this was a point on my line, 4 over negative 7 would mean to rise 4 and run 7 negative, which would be 7 to the left, because 7's negative. So if I did that, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. That'd give me a point right here. And that would generate this line. Now if I compare that to negative 4/7, what would that mean to do? That would have meant go down 4, because the 4 is negative. 1, 2, 3, 4. And run positive 7, which means right 7. 1, 2, 3, 4, 5, 6, 7. Which still would have given me another point on the line. It still would have generated the same line. So that's how they're the same. So if you get a negative slope, you can put the negative in the numerator, or you can put it in the denominator, but don't put it both places. Now, main campus, what did I just say to you? Repeat those words to me. If you get a negative slope, what? You can put it in the top or the bottom, but not both. That's right. That's right. One or the other, just not both. Mr. Black, it's already 2:32. We've only got 28 minutes left in class, and this is really going fast because I love algebra. Well, I'm glad you enjoy it. It's a great way to spend the summer. It's actually 2:34, so we've only got like 25 minutes left in class, so even less than that. Big fat deal. So we can find slope. Who really cares? How is it going to be helpful to us? Well, I said earlier that 2 points determine a line. Actually, Michaela said that. Way to go, Michaela. But now if we got a point in the slope, we can always get another point and figure out what the line looks like. So that's what example 5 asks us to do. They say to graph the line, and we're told that it goes through the point -1, 4, and we're told that it has a slope of 2/3. Class, the slope does you no good unless you have a point to work off of. Now, K-row, repeat that sentence that I just said to you.
The slope does you no good if you don't have a point to work off of.
Wonderful. So when I get this problem here, should I try to do something with the point first or the slope first?
Point.
You should do the point first. That's right. Always do the point first, class. Sometimes you'll see a student try to do something with the slope first, and that can't get you anywhere. We're always going to do something with the point first. So we're going to go 1 left and 4 up. That's a point on my line. Let's talk to Taylor and let's talk to Michaela again. My slope is 2/3, so 2 which direction and 3 which direction?
To the right and 3 up.
Okay, now remember that it's rise over run. So now what do you want me to do?
2 up, 3 to the right.
2 up, 3 to the right. 3 to the right because the 3 is positive. If the 3 was negative, then we'd go left. So we're going to go up 2, 1, 2, 3 to the right. 1, 2, 3. Boom. There's another point on the line. And now we can graph the line. Oops. Look there. Red, white, and blue. So always remember the top number's up and down, the bottom number's left and right. So you're going to have a few of those in your homework today where you have to plot a point and use the slope to get another point. Okay, let's pause. So what 2 concepts do we have left to discuss? I want to go back to the definition that we started this section with for a minute. Way up here. I said a linear equation is any equation that can be written as ax plus by is equal to c, and the x and the y are raised to the first power. Now what I didn't tell you is that the a and the b cannot both be 0. If they were 0, 0 times x would wipe out this term, and 0 times y would wipe out that term. I have 0 equal to c, and that wouldn't even make any sense. That'd just be pretty boring, actually, and false, unless c actually was 0. So they can't both be 0, but that doesn't mean one of them couldn't be 0. So let's say first that the a was 0. That would wipe out this term and give me a statement like this with just a y in it. So I'd have an equation that could be simplified into something that look like this. Y equals whatever number. Let's say it was equal to 4. So the question is, what does that line look like? Well, let me ask you a question. If it's y equals 4, do you think it's going to cross the y-axis or do you think it's going to cross the x-axis? Don't make it hard. If it's y equals 4, do you think it's going to cross the y-axis or do you think it's going to cross the x-axis? It's going to cross the y-axis. Okay? So y equals 4 is the horizontal line that crosses the y-axis at 4. It's this line right here. So if you get a line in your homework today that says y equals some number, any number, call it b, that's a horizontal line. A y equals line is a horizontal line, and we just established earlier that a horizontal line has a slope of 0. Okay, I need a female in the class then to tell me what they think that an x equals line would look like if I graphed it. It would be vertical, and it would cross the x-axis. It would cross the x-axis at a value of 3. It would cross right here. So this line would look, oops, why did it do that? Didn't tell it to do that. It would look like this. So anytime you have x equal to some number, that's a vertical line. And we just learned a moment ago that vertical lines have undefined slope. Okay, I pause for questions, class. Thoughts, feelings? Here is your second assignment that's due for tomorrow pertaining to section 8.2. It's page 377, 13 through 28, 40 through 47, and 67. So here's my suggestion. If you've got this time free, I'd jump right on this homework. If my neighbor was going to be around, I'd work with them. I would put a star by everything that I have trouble with, and when I start tomorrow's class by taking questions, I would make sure and ask about that problem. After I got help on it, I'd go back and rework it myself. All right. 1 down, 15 to go. It's nice to get to meet you all today, and I'll see you again tomorrow.